Okay, last time we started discussion about the statewide program in which the network is whatever you have inside the boundary. Okay, and in these programs we have again control counts, and from control counts we calculate adjustment factors. So we looked at some examples of calculating adjustment factors. Then we came to the point where how can we group between different control counts. So we have less data to deal with. Okay, and for grouping, then we take the average and we check the average against each value. If it's in the range, grouping is possible. Not in the range, grouping is not possible. Okay, moving on. Where do we use the adjustment factors? The examples which we did, it included adjustment factors for each day and adjustment factor for each month. Okay, so when you calculate the adjustment factor, you already have this thing. Okay, for the control counts, when you calculate the adjustment factor, you already know AADT. Okay, but the coverage counts, we don't know their AADT. Okay, so what we do, we take the count of coverage location and we multiply with the adjustment factor for the day and the month in which it was taken. Okay, for example, what is the date today? 23 March. Okay, for example, a count is taken today. Okay, so and what day is this today? Sunday, right? So we will take that count and you go to the control factor, the control count, and we look at the adjustment factor of Sunday. I take the adjustment factor of Sunday. Okay, and again go to the control count and I take the adjustment factor of March. This count will be multiplied by the factor of Sunday and the factor of March. Clear? This will become the AADT for the coverage. Okay, so control you already have. Using that we calculate adjustment factors. From the adjustment factors, we will calculate the AADT for the coverage. Okay, so a very simple example. Let's say for a control count location, the factors were taken as these. So you can see the first two columns are adjustment factors for each day, and the remaining columns are for each month. Okay, and then in the same network, where these adjustment factors are applied, in the same network I have a count which is taken on one day only, and that is 1000. Okay, in that one day 1000 vehicles were observed. Okay, so how to convert this 1000 into AADT? Okay, so what did I say? What we will do? We will look at the day and the month. Okay, so this was taken on Tuesday. So what is the factor of Tuesday? And it was taken in July. So what is the factor of July? Okay, so this one multiplied by the factor of Tuesday and the factor of July. So AADT will be 1000 and becomes how much? Say again.
1023.5.
Okay, any problem? Where? Where? Okay. Another example with the adjustment factors again. Okay, but now we don't have 1 point. We have how many points? 6. Okay, for each point, this much data is taken, and the day and the month are given. Okay, clear? Huh? So, can you give me AADT for these 6 points? I'll make this table bigger. It's the same which you have seen in the last slide. So, if you can go back to the last slide, you can see it from there as well. Okay, location 1.
11,100.
Say again.
11,115.
Okay. 4-1, right? Okay, next. 10,163. Next. 14,375. 77. 16366. Okay, last one. 13,919. Okay. Any problem up to here? Okay. Now this is what? What are the units here? Vehicles per? What are the units for AADT? Per day. Okay. Vehicles per day. Okay. And for the whole year, right? It's the average of the whole year. Okay. So if I want it for the whole year, this is per day. If I want it for the whole year, I will multiply by 365. Okay. So each of these values will be multiplied by 365. Okay. This will make it for the whole year. Okay. Clear? Now keep in mind we are doing it with AADT. This value is already AADT. That's why we are doing it. Okay. You cannot pick this value and then multiply by 365 because this is not an average. Okay. This is average for the annual, right? So I can do this with here. I cannot do it with this. Okay. So if I multiply by 365, it will become for the whole year. Total for the whole year. Okay. Then if I they are asking for VMT. Okay. Now VMT stands for what? Vehicle miles. Travel. Okay. Vehicle miles travel. We already have vehicles. This is vehicles, right? Okay. Multiply by miles. Okay. Multiply. So we take this number, multiply by the miles. This will become VMT. Okay. I mentioned earlier VMT can be for 1 day. So if I don't multiply by 365, just multiply by the length, it will become VMT of 1 day. Okay. After this, if I multiply by the length, it will become VMT for the whole year, 365. Clear? So for the first point, it will be into 365 into the length is 3 miles. Okay. Next one, 365 into the length is 2.7. Got it? Yeah. Done. Yes. Everybody. Any questions? Any problem? Okay. So the same will be applied for all the stations. Okay. And keep in mind when they say station, a station is on a segment. So the length is given for the segment. Okay. This is what you should get in the end. Okay. So we have talked about studies which are done for segments, studies which are done for networks. Okay, and the network can be limited or statewide. And we also talked about studies which are done for intersections. Okay. Now we come to another type of counting studies, which is called as specialized counting studies. Okay. We call them counting, but in many cases you will see the counting is not involved. Okay. In some of the cases you will see we are not counting. Okay. But specialized counting studies are those studies in which you are not interested in number of vehicles, but you are interested in the demand of the area. Okay. How many vehicles are entering, or how many people are entering and how many people are exiting from the area. Okay. So we are not interested, or we are not focused on how many vehicles are on the road. We are interested in how many vehicles are entering the area and how many people are exiting the area. So we are interested in the entry and exit. Got it? Whatever we have done, you are saying 1000 vehicles on this segment, right? Okay, or this many vehicles on this segment or in this network. Okay, we did not say from where they came, right? Or where they are going. So in specialized counting studies, we are not focusing on a network or a road, we are focusing on entry and exit of the area. Okay, there can be many types of specialized counting studies. We will discuss 3 of them: origin, destination, coordinate counts, and street line counts. The first and the third one are similar. The first and the third are similar to each other. Okay, we'll come to it. So we start with origin and destination. Okay, origin is what? What do you mean by origin? 0, 0, right? Starting point. And destination means end point, final destination, right? Okay. So origin, destination means the start of the trip and the end of the trip. We are interested in finding out the start of the trip and end of the trip, and not the exact point, the area. The area. Okay. We call them traffic analysis zones. The areas in which you divide your region, we call them traffic analysis zones. So you have the entire map of Bahrain in front of you. You will divide this map into small zones. Okay, for the purpose of traffic study. That's why we call them traffic analysis zones. Okay. So in origin destination studies, we are interested in finding out which zone is the starting point, which zone, and which zone is the ending point. Okay. So we are not focusing on the exact point, but we are focusing on the entire zone. How to do the origin destination counts? We have again different methods. Okay, but the 3 are listed here. One is license plate method. Okay, license plate method. You have observers on the entry point and the exit points. These observers are noting down what? What are they noting down? License plate number. Okay, so I am standing at the entry point of area 1. I am noting down which car came out of area 1. Okay, and same thing for the people who are exiting. I am standing at the exit point. I am noting down which cars are exiting. Okay, in the end you go to the office, you match your license plate numbers. I found this car to be coming from this area and this car to be going into this area. So this becomes the start point, this becomes the end point. Clear? Okay, the second one is the postcard method. Okay, you can change it. Postcards were usually small cards on which 2 or 3 questions were written. Okay, now which questions we are looking at? What are our questions? What is your origin? What is your destination? Okay, now since it's a card and you have the user has time to fill it, you can maybe add 1 or 2 questions as well. How are you going? How much time it took from this area to this area? No. You can add more questions, but normally it's a very small card. Okay, and as I said, it's a paper card. Okay, so you give it to the user. Under the card, there's an address. Okay, he will fill it and he will send it. Okay. But now we don't have to ask him to send it. Instead of the address, you can give him the link, or you can give him the number. So after he fills it, he will send it to that number via WhatsApp or upload it somewhere where you will get it, email address or whatever you want to give. Clear? But it's a card, you give it to the user will fill it whenever he has time, and he will send it to you. Okay? So in that card, they are written from which area you are coming, which area you are going. Clear? Now, you are asking about the zone, right? The user may not know about the zone. Okay, so he may say, I am coming from Sahir. Okay, now you have to do some processing in the end. Sahir falls in which zone? The user doesn't know, right? So you have 20 zones. You cannot be on a list of 20 zones. Okay, so he will fill whatever he wants or whatever he can. Once you receive it, you have to see, okay, Sahir falls in zone number 15. Okay, it's going to be Isatan. Isatan falls in zone number 2. Okay, so you have to do something after. Okay, and the last one is interview studies. It's a detailed questionnaire. Okay, so in the first method, we were giving the questions to the user. Right? Interview means you will ask him then and there. Interview means it will be asked then and there. Okay, it's not like I will give you and you fill it and you bring it back. Okay, interview means face to face. Interview means then and there, face to face. Okay, it's not an online survey. Online surveys are called online surveys. We don't call them interview. Interview means that face to face, and the respondent will tell and I will fill then and there. Okay, nothing afterwards. Clear? Okay. In the interview studies, normally then we go for more questions. Okay, and then we can ask about other data which we need for other studies. So interview studies just doing for the sake of origin destination is not usually done. Okay, we don't do interview studies just for the sake of this data. Okay, because you have to stop that person and sit with them or her, and you have to ask many questions. So I will not do all this just for two things. Okay, you are making all this effort. You will add more data. And obviously, you may not use all this data. Somebody else will do it. Okay? So, interview studies combine data from different studies. Okay? Clear? Whatever method you use, any of these methods or some other method, in the end, we will prepare origin destination matrix, OD matrix, which you see on the slide here. Okay? The 1, 2, 3, 4 are the zones. The numbers are the zone numbers. So this area is divided into 4 zones. Okay, each number tells you from which zone they are coming and in which zone they are going. Okay, look at the first number. How much is it? The first number is how much? 50, right? Okay, where are they coming? What is their origin? Huh? What is the origin of these 50 people? These are the origins, right? Okay. The origin is 1. Okay, got it. And what is the destination? 1. I'm not going anywhere. Okay? Yes. The other people, okay, let me go out. And they say, okay. Let us not go anywhere today. Let's go back. Okay? Those type of people. Okay, these 10, they are coming out of which zone? 1. They are going in which zone? That. Okay, so this is the matrix which is prepared. This 4 by 4 is prepared using one of these methods. Okay? And then at the end you see the summation. Okay? This plus this plus this. And this and this and this. Okay? The summation tells you the total entry or the total exit. The summation tells you the total entry or the total exit. So 88 is the total exit from zone 1. And 95 is the total entry into zone 1. Okay? Now, if you look at the methods, you are doing license plate method, you have to write the license plate numbers, right? Okay, so it's not possible to write all of them. It's not possible to write all the license plate numbers. You do postcard, you do interviews, then you are depending upon the other person, right? Some of them will not respond to you. Some of them will say we will not have time. Okay, so you will never get 100% of the data. You only have a sample. This origin destination matrix is a sample of the actual numbers. It may show the trend, but it will not show the actual number. For example, you see the highest one is this one, right? For zone 2. The highest number is for zone 2 for exit. So the actual number for zone 2 will also be the highest from the other zones, but it's not 99. It is not 99. It's something else. I don't know the actual number. I can see the trend. Okay, whatever the actual number is, it will be more than the other zones. Okay, and the lowest one is which one? This one, right? Same thing. I'll say, okay, the actual number is not 84, but whatever it is lower than the other zones. Clear? Now, how do I get the actual number? For that, we have to do a counting study. Okay, we have to do a counting study. In that counting study, we count number of vehicles entering and exiting each area, total. Okay, number of vehicles entering the area, number of vehicles exiting the area, total. Okay, and under each column and beside each row, you see these numbers. The last row and the last column are the numbers from the counting which is done in the field. Okay, so somebody was standing at the exit point of zone 1 and they counted 210 vehicles. Total number of vehicles which came out of zone 1 is 110. Somebody was standing at the entry of zone 1 and they counted 250 vehicles. Okay, so total number of vehicles entering for zone 1 is 250 and so on. Clear? Okay, so you do any of these methods, you will get a sample. Then you will do a counting study for actual vehicles entering and actual vehicles exiting. Clear? Now for these vehicles I do not know, I only know one of these things. Either I know the origin, I know the destination. Okay. For example, 210. What is their origin? What is their destination? I don't know. 250 vehicles. What is their destination? 1. What is the origin? I don't know. Okay. Obviously, all of them are not going in the same zone, right? Or not coming from the same zone. Okay. So I don't know the distribution. Okay. So I need the matrix. I still need the matrix. This counts doesn't solve my problem. I still need the real numbers in the matrix. Okay. So how do we do it? For each row and each column, we calculate a correction factor. For each row and each column, a correction factor is calculated. What is the correction factor? The count upon the summation. Okay, the count upon the summation. So for the first row, count is 250, summation is 95. Summation of the table. Okay, so count is, this number is not from the table, keep it in mind. This number is not from the table. This number is the summation. Okay, so 250 upon 95 will be the correction factor for row 1. Okay, for column 1 it will be 210 upon 80. Clear? Each row and column has a correction factor. Okay. If all correction factors are between 0.9 and 1.1, then you can stop your analysis, you have reached the end point. Okay? If all correction factors, keep in mind, I'm saying all rows, all columns, have correction factor between 0.9 and 1.1, then no further calculation is required. We have reached the end. Okay? But if you look at these numbers, 210 upon 88, will it be 1.1? More than that, right? More than 2. More than 2, right? So we need to do the calculation. Now what do we do with the factors? What do we do with these factors? You pick each number from the table. So how much was it? 2 point? 2.8. And for the column? Sorry, for the row? 2.23. 63. Okay, so if I have 50 here, okay, so 50 will be multiplied by the average of these factors. Just see. Okay, 50 was the actual number. Okay, in the first row and the first column, it's already changed. 50 was the actual number. Okay, it was, this factor is 2.39, this factor is 2.63. So 50 will be multiplied by the average of these two. Okay, so I got here 125. Okay, how did I get 125? Doing this. Okay, and this will be done for all the numbers in the table. Okay, if you are taking the number from the second row, you have to use the factor from the second row. So 27. Okay, 27 came how? The number was 10. 10 multiplied by what? Tell me.
2.38.
Got it? Okay, this is how it became 27. Okay? Clear? Okay. So as I said, they did this for the entire table. You can see the entire table is changed. When you change the numbers in the table, their summation will also change, right? So each row in each column has a new summation now. Okay? So this is the summation, the new submissions. Okay, the volume, will it change? Will these numbers change? No, because they are from the field. It has nothing to do with the table. So these numbers are as it is from the start till the end. Okay, there. Now since you change these numbers, that means the factors will also change. Okay, so again you have to do what was it? What about what?
Volume upon summation.
Volume upon summation. So 250 upon 267. Okay, and this one will be 210 upon 232. Okay, so these are given. I forgot to put them, but you get the idea, right? Okay, volume upon total. So volume is as it is, the total has changed. What was the range? These factors must be what? 0.9 to 1.1. Are they?
Yeah.
Are they 0.9 to 1.1?
No. There is one more than 1.1.
There is one which is more than 1.1, and there is one which is less than 0.9, right? They must be in the same range. Even that lower is not acceptable. Okay? So the same process will be repeated. Whenever you have a factor, any one factor out of the range, we have to repeat the process. Okay? So now you will do it with the new numbers then. Okay? So this number was 125, right? This was 125. Okay, so it was multiplied by the average of 0.9 and the factor of this row. Okay, average of 0.9 and the factor of the first row. Okay, which was so 125 multiplied by 0.9 plus okay, clear? Okay, so this will be 116. Okay, and again the summation, the numbers, it will be repeated for all the numbers. The numbers will changes means the total will also change. When the new total will, you will have the new factors. Okay, should I stop? Is this the last step?
No.
No, why not?
There's one below the.
Which one?
1.87.
0.87, right? 0.87. Okay. Can you just leave it?
No.
Let's take this column out. No? Why not?
It's not a student too.
Huh?
By that you should go out and
Not as student. Okay? You can name this column yes, right?
yeah, it's important.
Okay. Anyways, so you cannot leave one row or one column out because your matrix will be incomplete. We want a complete matrix, so we have to put it there. So because of this one column, the whole iteration will be repeated. Okay? The iteration requires all the numbers. The iteration requires all the numbers. So you have to do it with the entire matrix again. Clear? Okay. So doing it the second time or the third time, this is the final product. Okay. You can try it yourself. Okay. Now you can see it's a long process. You can make a mistake. Okay. Like I have been giving you some checks. Okay. Then you go from the first iteration to the second iteration and you recalculate the factors. Okay. These factors should get better. Better meaning they should get closer to 1. Okay. If you look at this one, now you look at the factors. Okay. These are the last ones. So you look at this factor. It was 0.97, right? Now it is how much? 0.99. Did it get closer to 1? Yes. The next one, 0.91. It was 0.87, now it is 0.91. So you can see all factors are going close to 1. Okay. Let me take one which is a higher one. Okay, 1.06. Okay. 1.03. So some of them will go higher, some of them will go lower, whichever is closer to 1. Okay, so 1.16 will get lower to get closer to 1, right? And 0.96 will get higher to get closer to 1. Okay, so you check from first iteration to the second iteration. What is happening with the factors? If any factor is not getting closer to 1, if it is constant, it is acceptable. But it should not go far. It should not be like it was 1.02 and the new one is 1.1. No. It is in the range, but there is a mistake. Because it's not going close to 1. Got it? Okay? So this is a check you need to keep in mind. Okay.